Good morning, good morning, good morning, good morning, everyone. 6 a.m. I have my coffee. And we're going to be reviewing abstracts. And I see you coming in. I'm always so happy, especially today, because yesterday was the 4th of July. Today is the 5th of July. Give me a comment if you hear me, because I have a new setup. You can see this microphone. Let me know where you are tuning in from in the comments, in the chat, so that I know that you guys hear me and we can proceed with our DigiPath Digest. I'm going to post a comment myself to say hi to everyone. Let me know what time is it actually? What time is it where you are? I want to know. It's 6 a.m. here, and I see my comment, but I need to see something from you to be sure that my setup is working. I see the camera is working, but I don't know if the audio is working. Give me a yes for the audio, and I'm gonna tell you what we're gonna do today. We're gonna review abstract, and we have an agenda today, official agenda. The agenda is, you can see it. Oh no, what did I do? Okay, agenda. Okay, yes, people are hearing me. Fantastic. Thank you, Nick. So the agenda is, I'm gonna talk a little, then we're gonna do the abstracts, and then I'm gonna talk some more, because if somebody doesn't want me to talk too long, then they can just leave after the abstract. So because today is after 4th of July, I assume people in the US are not gonna wake up and join us. So I'm gonna send them the recording. So let's just start. Let's just do it. And today we have the abstracts from June 29th. June 29th, which is last Saturday. So I have my PubMed alerts, and I did a little bit of preparation. So I pre-marked my stuff here, right? So and pre-marked the abstracts that we're going to be talking about. So let's start with molecular classification of breast cancer using weakly supervised learning, and the keyword is going to be weakly supervised learning. This is something that was done in a group from Korea, from Seoul. How do you pronounce Seoul? I would say Seoul in Polish, but it's Seoul, I think. Anyway, this Korean group did weekly supervised learning. So obviously, they did weekly supervised training for molecular classification, right? Molecular classification. But that's more or less what you do with weekly supervised training. So they, because molecular classification is crucial for effective treatment, it's important, right? And they did weekly supervised, like usually people do weekly supervised, because they don't want to do manual annotations. If you have ever done manual annotations, you know that it's time consuming. At some point you get discouraged as the annotator, and it's not scalable. Although there are companies that are offering this as a service and recruiting different doctors for different specialties, for pathology including, but also for radiology. So that's what they did, and they wanted to classify molecular subtypes of breast cancer, and they have had two data sets, two whole slide image data sets. Sorry, something else popping up on my desktop, doesn't matter. And those data sets were from 1 kg from Korea University. Let's see if I can make it bigger. And one was just our TCGA that we know. This is the Cancer Genome Atlas that everybody is using for different different research in digital pathology. So, and they did a visualization with an attention-based heat map and reviewed the histomorphological features, which is a method that people kind of like reverse. I don't want to say reverse engineer. I want to say reverse explain. Reverse explain. So they see what the model is doing, where in this case they have an attention-based heat map. It's like with the dog, where you classify dogs and cats. I'm trying to change my view. When you classify dogs and cats, and you see that the model, you have a heat map, and you see that the model actually is showing the dog's head, and that's where it took the information from, that it is a dog. In contrast to, for example, that was what Anand Madabushi once told me, either in the podcast or in the conversation, that, oh, they were classifying husky versus wolves, and this model was so good. It was so good that it was too good to be true, so that when they looked at the attention heat maps, the husky dogs had snow in the picture. So the model was focusing on the snow. It's this like red dot next to a tumor slide kind of thing. The model is gonna focus on the things that are most easy to recognize. So when you see that the model is actually focusing on things that are morphologically relevant, which pathologist is going to tell you, and that's good because it makes sense. So going back, I'm checking which is the best view. I guess this one. Yeah. So attention-based heat map, and they reviewed histomorphological features. So these were the two, KG and TCGA, were their data sets, and their results. They did the area under the receiver operating characteristics, and the value was 0.749. And they had a challenge because they had an imbalance among subtypes. So class imbalance in general is a problem in those machine learning models. So they merged the two data sets. They merged the data sets, and the resulting model was improved. And also they were happy because the attentive patches correlated well with widely recognized morphologic features. And what were these features? These were for triple negative subtype. Triple negative subtype was high incidence. I say because the focus on my screen improved. High incidence of high-grade tumor nuclei. There was necrosis and intramural tumor infiltrating lymphocytes. Intramural, intratumoral, so in the tumor. And there was the other subtype, luminal A subtype, and this showed a higher incidence of collagen fibers. So these are things that happen in those cancers, and they were happy because the model made sense. And this is fantastic. So moving on to our second abstract. We have clinical implementation of artificial intelligence assisted detection of breast cancer metastasis in sentinel lymph nodes. And of course, they have this funny name, Confident B, single center, non-randomized clinical trial. Can you imagine? So this is a group from Utrecht, the Netherlands, Utrecht. They did this. They have a clinical trial. They have this. So let me tell you about the detection of breast node metastasis in. I need to find key shortcuts for switching between, because this is annoying for me and for you, I bet. So anyway, 2017 and 2016, there was this famous chameleon challenge. Chameleon challenge was detecting breast cancer metastasis in lymph nodes. And this is something that is happening on a regular basis when you do the diagnostic process of breast cancer. And these challenges, there were different groups challenged to which algorithm, which group is going to make the best algorithm to detect those cancer. Give me a yes if you've heard of this challenge. It's pretty famous. If you haven't, that's okay as well, because you now have. But I promised I'm going to be talking some more later. So, but give me a yes if you know chameleon challenge, or give me a chameleon, however you want to spell it. The spelling is funny. So, going back to this abstract. So they have something. What do they have? They have an AI assistant detection in a clinical trial. I think it's a big deal. Also, if you look where it's published, it's Nature Cancer. This is big deal, right? Utrecht has this clinical trial. So let's see what they did. Of course, assessing sentinel lymph nodes for breast cancer metastasis is a treatment guiding. So treatment guiding, we do it to determine what the treatment is going to be. And labor intensive, right? You have to look for little tiny foci of epithelial cells, which are the tumor cells in a lymph node that is full of a lot of lymphoid cells, like a bunch of lymphoid cells together in a sheet, and then you are looking for an epithelial cell. It's costly. I'm like, why is it costly? Because you have to stare at it a long time? No, as well, but it's costly because sorry, that disappeared my paper. It's costly because you do IHC, and IHC costs money. So you do it in morphologically negative cases. So the moment you don't find it, you have to do IHC. And this is a clinical trial, right? And in this clinical trial, an AI-assisted workflow for detecting breast cancer metastases in sentinel lymph nodes was studied. When was it done? It was done from September 2022 to May 2023. So it's less than a year. We had 190 specimen, 190 lymph nodes in this trial, and we had an intervention arm. Let me use some, maybe green. Sorry. I have to do this. That's okay. Intervention arm, 100 people or 100 of those lymph nodes, and the control arm. And what happened? In both arms, we used whole slide images, so digital whole slide images of H&E sections were assessed by an expert pathologist. I think if you're a pathologist, you're an expert. Expert pathologist is even higher level. Anyway, this pathologist was assisted by the metastasis detection app from Visiopharm. Here, let's clap and congratulate Visiopharm on making, like, they are in a clinical trial. How cool is that? And the Visiopharm, you can use it, you can buy it. So you can have a tool that was in clinical trial, this app. I don't know if they're selling this app. We will ask them. But basically, in the non-intervention arm, it was just visual, just the pathologist, and in the intervention arm, it was, nobody knows chameleon, by the way. Then give me a no, so that I know that you're still listening to me. And so the metastasis detection app was in the intervention arm. And what were our results? First, we had a primary endpoint, and it showed reduced adjusted relative risk. I don't really know what this metric is, but it's reduced adjusted relative risk of IHC use. Honestly, I don't know this metric, but it showed reduced adjusted relative risk of IHC use. And it was 0.68, 95% confidence interval. And for AI-assisted pathologists, right? And then there was a cost saving. They actually calculated that it was $3,000 less. Well, they saved $3,000, not dollars, euro, because that was Utrecht. It was, and so they saved money with AI. And the secondary endpoints showed that there was also time reduction, but they didn't write in the abstract how much time reduction. That's okay. And then 30% improved sensitivity for AI-assisted pathologists. This is huge. 30% is a lot. From the cases that you... So 30% didn't have to have IHC anymore because you already saw it on H&E with the app. That is big. I think this is a lot. So we have the this particular paper that says, oh, AI saved cost and the pathologist was more efficient. And then we have this other abstract that I thought was interesting to include today because I don't think we talk too much about that. I kind of have it in the back of my head. So the title of this abstract is The Environmental Impact of Digital Technology and Artificial Intelligence in the Time of Digital Pathology. And this particular one, where's the rest of my abstracts? I don't have it. That's okay, guys. Let me find it in my... Give me 1 minute. I'm gonna stop screen for a second and I'm gonna search it for you. In the meantime, tell me what time is it where you are. Tell me what time is it and where are you tuning in from? And I will quickly find my other abstract. Maybe I will not have my markings. It can be that I will not have my markings. No, I have it. Okay, differently. 1 second. I have everything. I don't know why I didn't open. That's okay. I'm gonna open this one. Maybe it will work. Okay, there are people in Dublin in Europe. I was suspecting Europe today. I was suspecting a lower. Okay, is it working now? Yes, it is. Sorry, guys. I don't know why this app did this to me, but we can present it right now again. Share screen, and we're going to do entire screen, and we're going to do our abstract. Apologies for this. And you guys are 17 in Dublin. I assume in UK it's the same. Fantastic. Thank you for joining me. Okay, so we have our abstract. And we just said that, oh, clinical trials said you can save $3,000, 3,000 euro, and it's all fantastic, 30% improved sensitivity. But I have to check 3,000 euro like per case or per what? Because if it's just 3,000 euro, that's not too much. That's okay. But then we go and the French authorities say that we need to be mindful about the environmental impact of all this. It's not at zero cost, right? So this is a group from France, and I have my special comment. Let's see if the comment opens. But basically, what they tell us is that this is the future. We're doing digital pathology, but actually, we need to be mindful about this not being free. It's not a free lunch, right? There's never a free lunch. I wish there was. So they say, of course, they bring up the global warming, overstepping of planetary limits, threatening human health and the functioning of the healthcare system. And this functioning of the healthcare system, I think it's probably not specific to France. I've been reading several books about US healthcare system and that it's like semi-collapsing. But anyway, so the French government's Délégation Ministérielle is saying that in spite of everybody saying, oh, digital pathology processes dematerialization. So like, let's say we can maybe skip IHC, so we don't have to use so many reagents. We don't have to make so many antibodies or different things like, right, we can predict molecular properties from tissue, all that stuff. Actually, it is a very material industry. They say it's very material, and it generates greenhouse gas emissions. It also consumes water and mineral resources and has social impacts. And the digital sector is impacting at every stage of manufacturing equipment, use of it, and end-of-life equipment, and it can only be recycled in a very limited extent. And that they say that we need to understand consequences and phenomena such as rebound effect. Let's see if it's going to open my note. It might not, but basically I looked up what the rebound effect is. But it is the effect that the lower the energy costs and the higher the efficiency of the energy, the higher the consumption of it. So actually, like, you don't save anything. I don't know, you can probably like compare it to the accessibility. Like, the cheaper the food is, the more people eat and the more obese there are, and then you have a problem. So here, I don't know if it's a good analogy, but basically everything is getting more efficient, cheaper, and then you start using it more. So actually the cost is the same. So that's what they are saying to be mindful of, which I think we should be mindful of, right? So they ask us to do implementation of a sober, responsible, and a sustainable digital pathology. How are we going to do this? I don't know. Maybe they said in this paper, so we would need to read the full paper. But I don't know. I think we're still like at the very beginning. Everybody wants to make it happen. So this is at least not that much talked of. Out of those 10 abstracts, there was only one of this. I mean, it's a niche topic. And I have a lot of abstracts, but we're not going to do all of them. I think I will usually just restrict myself to 3. And then I'm going to show you something else. So one was, let me find it. Here, this one. Digital versus manual tracing of cephalometric analysis, a systematic review of meta-analysis. This is not strictly digital pathology. This is actually cephalometry is measuring different, like, more morphological, like shape of the head in X-rays or in tomography. So this is cephalometry. And what they did, this is Journal of Personalized Medicine. I checked, it's 3.4 impact factor. So I always compare it to my ToxPath journal, where all the toxicologic pathologists publish their stuff. And ToxPath, maybe is 2. Anyway, not like super high, but it's super niche as well. So I don't say it's like worse than higher impact factor. It's just super niche. But what happened here, and actually the point of this abstract is not this cephalometric analysis, because as pathologists and digital pathology professionals, we might not care. But what they did, because this was a meta-analysis, they did a systematic search using keywords. So they took keywords, right? They did digital and manual and cephalometry. So they wanted to have all the keywords in. That's why they used the and operator. And they searched a bunch of different databases, right? Some Medline, everywhere, Scopus, everything, Science Tech. They searched and they had results. The results was, okay, we found 20 studies, and between the 20 studies were between 2013 and 2023, and the conclusion is there is a trend. Sorry, it revealed trends suggesting that digital tracing may offer reliable measurements and specific cephalometric parameters, efficiency and accurately. I love this. It revealed trends that digital tracing may offer. So when I was studying for my boards, part of this is keeping up to date with the veterinary pathology literature, and we had kind of like criteria when to read a paper and study from it, and when not to read one. And when you would identify these words, trends and paper, it would be like, no way I'm reading this paper. But what I wanted to show you is, because they did the keyword research, I wanted to show you a new tool that I'm exploring. I actually talked to the people who designed this tool. So let me share a different screen. And I'm going to find you this tool. You can find it as well. It's called Undermind.ai. Undermind.ai, it's you have to make an account to actually use it. So let me share. Don't go away. I'm sharing. Share screen, and we're gonna share this tab. Okay, Undermind. Sorry, this content is no longer available. Am I streaming? Guys, let me know if I'm still streaming. I confused my tabs here. I confused my tabs, but I'll find myself. Okay, I am streaming, sorry. I am. But stuff happened, sorry. Anyway, so this Undermined, I want to show it to you. This is like a different, it's not really PubMed or, I'm so confused with the tabs. Anyway, let me focus on this. So there is, they call it radically good scientific search. So scientific search in, I would call it literature research as opposed to keyword research. And that's how the founders are also positioning it. So search now, and I already have an account. You can have accounts. So when I look at pricing, there is a free pro and heat, but at the free one. So, and I have some searchers, but let's I want to check this stuff. Yeah, search now. Let's search now. For example, for what tools have been tested? What AI tools? What AI tools have been tested for detection of lymph node metastasis? Detection of lymph node metastasis, and I'm making spelling mistakes, in breast cancer. Let's see what it says. So it's going to tell me that it understands what I'm looking for, and it tells me to like have a better query, because this is large language model based. This is AI based. It searches the databases with an AI model so that it's more semantic search rather than keyword search. well, I'll just repeat my stuff and let's see what it tells me. Many AI tools. Can you specify if you're interested in AI tools tested in histopathological images, radiologic scans, or other types of medical imaging? I love it. Okay, I'm interested. I'm interested in histopathology. Pathology. Okay. And then it gives you like this revised prompt. I want to find research articles that have tested AI tools for detection of lymph node metastasis in breast cancer using histopathology images. Like, I don't even know what keywords I would use, probably AI, lymph node, metastasis, but here I can just ask a question, right? So, because it's a large language model AI-based thing, it takes some time to generate a bunch of different papers that are relevant. I'm going to show it to you in a second. And let me show you this in a different way. Actually, let me show you what it's doing. It's basically not doing anything. It's doing its search. Thank you for the confirmation. And I want you to wait. And it says it typically takes 2 to 3 minutes to generate deep systematic search. So what I would use this for, so now I have the PubMed alerts, and actually I'm going to be publishing a video how to set them up. So I'm going to share it if you guys are on my list, then you're going to get this email for sure. And if you want to share it with other people, I would very much appreciate. So I'm going to keep receiving those PubMed alerts. And this week I was already more prepared, right? I had my abstracts pre-marked. I had 30 abstracts picked. So my way of getting better is just going to be doing it every week in the morning, maybe later. I don't have to do it in the morning because yesterday we finished 4th of July celebrations at 11, and I was going to sleep, and I'm like, okay, and then I remembered, no, I need to do the journal club. I need to do the abstract. So during the night, I was waking up not to oversleep. I'm like, there's going to be people waiting for me. I don't care how many. I need to show up. So I did that. I pre-read the abstract. It was pre-marked. The next thing I want to do is maybe like highlight which journal and like what impact factor the journals have, or something like to rank them in one way or another. I might be doing it or not, because I might just go by personal preferences and you go with it, or you have your own alerts, which there's going to be a video how to do it. And you can also put your own keywords. The keywords I put in were artificial intelligence and digital pathology. So everything that has artificial intelligence and digital pathology. Sometimes, last week we had the plant pathology, now we had radiology paper included. That's okay, right? But that's keyword search. And I want to show the semantic search. What I asked those founders is to show side by side the results from the Undermind.ai, Google Scholar, and PubMed, and they say, well, we actually did it, and they have a white paper. Once this runs, I'm going to show you the white paper that they have a figure about how is it different from the other keyword based searches. But what I would use it for is exactly like for a systematic literature search that is more based on a scientific question, or when I am starting a project and I want to know, okay, what has already been done. So for example, in this case, okay, it's ready. Okay, so let's have a look at it. In this case, let me do this. And I have to go to this tab actually. So in this case, our question was search topics. I want to find research articles that have tested AI tools for the detection of lymph node metastasis and breast cancer using histopathology images. And oh, I have a lot of. So what happens? It has this. It tells me. So far, I've completely analyzed 100 of the most promising papers. And I found 52 to 57 that are relevant, meaning that's a lot. When I look for TalkSpot stuff, you're like 5 to 10 that were relevant, which is probably 61% of all that exists. Like, if this is already 61%, I would probably be done with my search. But basically, let's see if we have the one that we actually discussed, the one from Utrecht. Let me check who was the first author. C. van Dooyeweerd from Utrecht. Let's see if we have van Dooyeweerd. I don't know. But anyway, what you get here is like a topic match is this 100% match. Then year, okay, we can only take last 2 years, and we can go by years. So was there? Yes, this is our paper, guys. It found it. So yeah, so PubMed versus Undermind. We at least have a tie. It has 99% relevance, and it's very recent. And then the other ones. So when I was talking to the founders, and I was like, okay, so I did a similar test, like we did a little test. Okay, I had stuff from PubMed, and I'm asking a question, and I'm checking, oh, is it there? And it's there. And they said, well, you found it, you like knew what you were looking for, but actually, if you have 100% score, then all the other papers are also relevant. So here they have lower score. So basically, I found how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 that are relevant, and it ranks them by relevance, which they have like an algorithm. And this one is super new, so it has still 0 citation in their database. The new ones have 0 citations, but they're super relevant. So that is what we have here, and we will meet next week to discuss more abstracts. Feel free to let me know when you're watching this as a replay, or just when you receive emails from me. Send me some papers that you want to have reviewed at some point. So what I'm going to be doing, I'm going to start. So for example, now there was this, whenever there is a commercial entity, a company involved, I'm going to ask them if they want to sponsor a live stream about their paper. So we might be doing that. And that's it for today, guys. You have a wonderful day. Thank you so much for joining me. Thank you so much for staying till the end. And I will show up next week with new abstracts and figure out a way to do it better. You can give me feedback. I got some feedback after last week's live, what to do better. Some of the feedback, some of the feedback was, oh, go more in depth into one paper. I might be doing this sometimes. For me, the idea is to show up and give like this quick win, quick value that also does not require me to prepare a lot in advance, because I'm going to be doing this every week, especially in the morning. There is no way I can. And yes, last week I already, like after the last live stream, I was like, oh, let me put the presentation, let me put all those images, let me like do it better. And I started building a PowerPoint presentation, and then I'm like, no, that is not the point of this particular activity. The activity is to show up, go on a regular basis. And this is kind of a bite-sized information. And that's how I'm going to keep it. It will evolve. If we have sponsors that have relevant papers, then we're going to be talking about them. That's okay as well. And I'm going to let you know ahead of time. Thank you so much. And I talk to you on the next live stream, in the next video, and in the next email.